Good evening, everyone. It sounds like everyone's starting to get nice food in their belly and ready to have a great evening. So this is another evening of the Bay Area Python Interest Group. My name is Glenn Jarvis, one of the organizers. To be honest, I've been behind the scenes for quite a while and haven't done anything. Been a little lazy in the last 6 months. I haven't been here much. The person who's normally doing a lot of the lion's share of work, Jeff, was gone last month. He was on a trip to Germany, and this month he's on a trip to China. So I'm standing in for Jeff as he's traveling. So what we like to do while we're just breaking the ice, how many people have never been here before? Okay, I see about 5%. That's pretty good. New hands, that's great. So just to let you know in advance what we're going to do, we're going to have a couple of announcements. I've known, first of all, our host, LinkedIn, has been incredibly generous. All of the stuff you see in front of us has been donated for free. All of the food, all of the people who help you show up and come in, they've always been very, very good for us for several years, many years. So I want to thank them for that. In fact, some of the people who are here tonight have actually been hired from this event before through LinkedIn. So one of the things that BayPiggies likes to do is we like to actually try to make sure if you're looking for work or if you're looking to hire, we want to give you that opportunity. So in just a few moments, we'll ask you if you're looking to hire, and we'll just have you come back to the mic in the back and speak, make sure it's turned on, and just explain a little bit about your business. And then, of course, if you're looking to hire, looking to work, people are going to be looking for you, so you should come up and introduce yourself as well. But before we do that, is there any other announcements of any cool project you're working on? Anything? Yeah, oh, there might be one here.
Thank you, Glenn. Yes, I have a new meetup. It's called CS101A. So you go to the URL meetup.com/CS101A. We have 2 meetups, Saturday and Sunday. It's basically free training. We give you a table, Wi-Fi, power. You bring your laptop. And the first topic is Google GCP. So there is some Python in there because you need to use Python to deal with some of it. So that'll be the start. The eventual goal is to use basically free training to learn computer science. So that's why I called it CS 101. So I brought URL strips, okay? They're almost as good as business cards, and if anyone wants a URL strip, that'll help you remember about my meetup. So I'll be passing these around. Thank you.
Yeah, clap if you want. That's great. Jeff actually asked me to make another announcement as well, and we might be losing the mic on this one. Tell me how the sound is going in and out, I think. But Jeff has asked me to help with speakers. So if you are wanting to help do an additional speaker, please come look for us. We're looking for a couple of extra speakers to talk in March, especially if you happen to be going to PyCon. How many people have never heard of PyCon? Okay, 1, 2, 3, yeah, a few. So the rest of you know at PyCon. How many people are going to PyCon this year? All right, maybe it's not quite as much as normal, probably because it's a little further than it has been in the last few years. So PyCon is a national conference, and if you're speaking at that particular event, you often want to practice on a crowd that's a little bit more friendly and smaller, which is us. So we're looking for that. If you happen to want to practice your talk, let me know afterwards. All right, so let's see who's looking to hire. I know there's at least one person looking to hire. If you want to stand up, and the mic in the back of the room would be great.
Hello, is it on now? Okay, so I'm here from LinkedIn. I'm on the tools team, and my team in particular is looking for 2 people. I know our sister teams are looking for several people. We use Python almost exclusively across tools. So if you're interested in doing tooling of any kind, code review, CI, deployment, any of those kinds of things interest you, then come say hi. And yeah, LinkedIn's always looking for good engineers.
So we're here from NEO, the electric and autonomous car company. We're in San Jose, and we're on the digital systems team. So we create the central networking hub, router, and management computer for our car. We have wireless interfaces. We have a lot of wired interfaces throughout the vehicle. And specifically, our team does validation and system integration. So if you're really strong in Python, we're interested. If you're just getting into Python, but you're strong in validation or systems, we may be interested too.
If you live in the area, in this area, the commute is goes against traffic, so that's nice.
Yeah. I do. It's about 15 minutes or less from here.
Yeah. Also, we have really nice benefits and everything. So, and it's really exciting work. So, do you have anything else?
Talk to us if you're interested.
All right.
Hey there, my name is Mahmoud Hashemi. I'm here with Simple Legal, and we are a Python shop within 5 minutes of here. So if you made it here, you can make it to Simple Legal. The commute's going to be fine. Anyway, so yeah, we're a Python shop, about 50 employees, Series A, revenue up 300%. What we do is we're basically like what Salesforce is for sales. We do that for legal. In-house counsels, GCs, love our product. Never lost to a competitor or whatever they like to say. But yeah, Ark is here, Kurt is here, and we're hiring at all levels. So if you're interested in product development or integration, come let me know. I'm sitting right in front of the mic.
We'll also have an announcement at the end so that everybody who's looking to hire can stand up. Everyone's looking, if you can't remember and you want to find them, we'll help you do that toward the end. We'll have you stand up and say, here, if you're looking for hire, go over to that quarter of the room.
Hi, I'm Moshe Zadka. I'm going to be talking in a few minutes, but also my company Globality is hiring for my team, which is a DevOps. We literally just posted the job description. We're also hiring for a bunch of other things. And if after hearing me speak, you decide you still want to work with me, please come talk to me. I have like more classical business cards. I'll be happy to hand them out.
Hi, my name is Doug Reed, and how about that? Yeah, is that better? There you go. Hi, my name is Doug Reed, and I run engineering for Carta or eShares. We are a Python Django shop. We've got a large team over here, and we're growing very rapidly. We're Series C, and we've tripled revenue for the last 3 years, year over year. And it's a really good time to get into the company. So we'll be here, and we'd like to talk to anybody.
I'm Jim from Shape Security. We're also a very rapidly growing successful startup in web and mobile security. We protect web and mobile sites by distinguishing humans from bots. If you have a bank account in the United States, there's a good chance we are helping to defend your account from takeover. We have multiple positions open, so please speak to me about it. Thanks.
Great. There's a lot of people who are looking to hire. I've seen this flux go up many years. It's like, oh, a lot of people hired then, and then I think in 2007 it was not quite as high as that. So it was really good to see a lot of people at the mic saying, hey, we're going to hire. Now you don't have to feel on the spot if you're shy, going, well, I want to ask them and talk to them, but I don't want to say anything. Don't worry, you'll have your chance. We're actually going to meet right over here. So everybody who's just coming to the mic will come over to that right by that pole on that side, so that everyone knows where to find someone, and you can ask them, give your resumes or cards, whatever you need to do. But any brave souls who really want to stand out and say, hey, I'm actually looking for work. I want to stick my neck out and say, hey, hire me. Please come to the mic now.
Hi, I'm Joanna Lancaster, and I actually teach computer science at Foothill College, and I have a lot of wonderful, curious, dedicated students who are looking for internships this summer. And so please come talk to me if you are looking for an intern. I'm teaching C++ right now, not Python actually, but they're really quite good. So please come talk to me.
Hi, my name is Usha. Okay. I'm Usha. I have around like 9+ of year experience in test automation. Okay, test automation, and I have worked with different object-oriented languages like Java, C#, and Python. So I'm looking for, I'm open to the market as of now, and I have worked with various good companies like Cisco, HP, and other. So yeah, I wanted to join like a Python automation team as of now. So if anybody interested, so they can reach me. Thank you.
Hello, my name is Kerry Fitzgerald. I've just coming out of a little bit of a technical hiatus. I took a couple years off to look after a family business, but I'm looking to get back into engineering. I got my gray beard honestly, so I've done a lot of things and a lot of across a lot of environments, development, leadership, innovation. I have about 30 patents, and I'm looking to get back into development. So thank you.
Hi, I'm Terry Brindisi, and I think I fell in love with Python about 2011. But I design test execution frameworks, currently doing that for a company called Shipwire. I'd like to move on to somewhere else. I've done the same thing at many companies, but usually back-end like storage and compute type infrastructure, not really front-end web application stuff. In addition to the custom test frameworks that I build, I also just recently created a custom billing system, but I love Python and just want to do something new.
Very cool. So we have a lot of people who are looking and a lot of people who are looking to hire. This is a good crowd tonight for looking for work. Now, we are not a recruiting company. We are really a open source community, but we do like to spend a few moments just to make sure everyone can get hooked up. But you know, there are a lot more interesting announcements than that, like new projects you're working on, new conversations you want to have. So let's reserve some of those conversations for right after the talks. You'll have lots of time to network. So our first speaker tonight is someone who has gone to PyCon many times. I've seen many PyCon talks as well. And you're going again this year, right? Yeah, cool. So this will be a really, really good talk. I'm very excited, actually, myself, to see the talk. So Moshe, come on up.
Okay, that's good. Can people hear me? No. Okay, let me put this out. Okay, that sounds better. Yep. Okay, yeah. Awesome. Okay, so my name is Moshe Zadka. No. Let me see if I can place it a little better. Okay, that's good. No. On. Okay, hello. Okay, woo. Okay. Okay. That's good. Okay. I guess I have to hold it like that. Okay, that's okay. I can hold it. That's fine. I have small hands. Okay. So my name is Moshe Zadka. All my contact details are in cobordism.com. And today I'm going to talk to you about NColony, which is one of my favorite open source projects I'm working on. So NColony is a process supervisor. What is a process supervisor? It's something that lets you run multiple processes, restart any of those that have crashed. Optionally, some do that and some don't, adopt other things. And adoption is kind of this weird Unix stuff, and maybe we'll get to talk about it and reap them. Some of them do health checks, some don't. NColony kind of does and kind of doesn't, and we'll talk about that. So why do you need a supervisor? Why don't you just run your process yourself? Well, so there's three things that can happen to your process. Your process might crash, get a segmentation fault, get an unhandled exception, exit for some other reason. Your process can hang. It can just get stuck in an infinite loop. And you might want to restart it to get any reconfiguration going. Like you change the Nginx's configuration file and you want to restart it. So, why am I doing this? Right? There's already a lot of existing supervisors. There's systemd, the 800-pound gorilla, sometimes literally. There's supervisor D, which is like this closest to NColony that it's also in Python. There's runit, which is very popular in some cases, and there's monit. So why do we need another one? So there's a lot of design decisions that go into making a process supervisor, a lot of bad ways to do it, and I wanted something that will do it all the correct ways. So a lot of process supervisors, I think monitors like that, will run it as a daemon and then kind of look at the PID on occasion. That is bad for many reasons. There's like lots of race conditions that can happen, lots of problems with that. And the obvious solution is just to not do that, right? To just be the parent directly. The operating system will notify you when it dies and you can do whatever you need. So that's always a better alternative. And modern init systems like systemd has started going that route. The older sysv init, for example, does it the old way, and that's really bad. And like that's part of why systemd was made. So no PID files. PID files are, again, are bad. They're very race conditioning because you start the process and then you read the PID and then you write the PID number. In that, what you think is a small amount of time, but can be very, very long if the system is under heavy load, which is, of course, the worst times because that's exactly when all your crashes happen. It actually can take a long time, and the process running, and you're not really sure, and you don't have the PID, and that's, and like nothing can kill it, and then you die, and like it's all bad. The second design principle is I want to write it in Python, because if you write it in C and you make a pointer error and your process monitor crashes, then you have nothing to protect your process monitor. Your process monitor should be in the business of protecting other things and restart them. So it's bad if your process monitor crashes, so you want to avoid that. I want to do interpreter compatibility. Nowadays, it's kind of frowned upon, right? Like you're supposed to use 3.6 or GTFO, but a lot of people are still stuck on 2.7. I don't want people to not be able to use it. I want people to be able to use either PyPy or CPython with that, because sometimes PyPy is the right choice and sometimes CPython is the right choice. Wow, the mic is certainly going in and out in an interesting way. Stay with us. It'll be a fun ride. And then the other thing is I wanted to make sure that it's easy to programmatically configure it. Meaning I don't want like a human written INI file that's like really hard to change from a programming language, because, for example, when you build a Docker file, it's really nice to be able to automate the creation of it gradually. You sometimes want to put it in startup code. So it's kind of nice if you can write your configuration in a programmatic way. And I wanted to be able to reconfigure at runtime, which means I want to be able to add, I want to remove, I want to say restart this process, I think it hangs and maybe you have noticed it, please restart it. And I want to be able to reconfigure a process. I want to give it different parameters or different environment variables. The last thing I wanted to do was to make sure that the health monitors are all external. Because if your health monitor crashes and your health monitor is part of your process monitor, then your process monitor just crashed. We all agree that's bad. And the definition of healthy is pretty complicated. What does it mean for something to be healthy? Well, you probably want it to not, be dead, right? You probably want the process to be up, but you probably want something more. Is the web server healthy if it listens on port 80 but never responds to get/? That's a subtle definition, right? So you want to be able to define your health, to define your health externally. That's really nice, and it doesn't crash the process monitor. The other thing I wanted is 100% unit test coverage. And the reason I like 100% is because any smaller number than 100% is really meaningless, because you could just write more code and test that, and gradually you'll get to 99% by just writing a lot of code and testing it. But you don't know if your important code is tested. If you're 100%, you know exactly that your every line, right? So 100% is a number you can't fiddle with. 90% is a number you can easily fiddle with by just making sure that the unimportant code is really well covered. So I wanted to have 100% unit test coverage. Installing NColony is really easy. You run pip install, that's it. You have NColony set up. Running NColony is basically written as a twisted plugin. So once you install it, it self-installs the Twisted plugin, and so you just tell it NColony, and you tell it where the messages directory and where the config directory are. So there's 2 directories. And the reason they're separate directories, and I don't assume they're subdirectories if anything, is because it should be possible to put the config directory on a read-only volume, because in many cases you do not want runtime reconfigure. Of course, then you won't be able to runtime reconfigure, but you almost never want the messages directory on a read-only, because then you can't send any messages, which again may be okay in some cases, but it's very reasonable to want the config not to change, but to be able to send messages. So 2 separate directories. And then this is how you add something. You can literally like have Python NColony control, and you add it, and you tell it which command to run, which is in this case is mything.py, and it will make sure that it runs. Or you can do it from, like this shows you from a Python prompt, but presumably the reason you're doing it is not because you're on a prompt, because if you're on a prompt, you would just do that, but because you want to put it in a Python program. For example, maybe you want to loop through a list of things that you got from elsewhere and add them all up. So you can write Python code instead of weird shell scripts that are really annoying to write and loop. Or you can just literally write your own JSON files yourself. So this literally does the same thing as this, and the same thing as this. This all adds the same thing. So this is really nice because sometimes like the easiest thing for you to do is just move files around. You can check files into source control and put them in your Ansible configuration or in your Docker or wherever you put them in. So sometimes moving files around is fun. And all these 3 things do exactly the same thing, which is create that JSON file. So all those ways are sometimes useful. And you can remove it. Removal is easier than adding, so I just put all 3 ways to remove on the slide. You literally just remove the file. There's no like marking the file is deleted or anything. If the file is there, it's there. If the file is not there, then it's not there. And all these ways of removing again are the same thing, and you might want different ones depending on exactly what is easiest for you, whether it's running a shell command line, whether you're inside a Python program, or whether moving files around is the easiest thing for you. So NColony has, like I said, external health monitor. The simplest external health monitor is a heartbeat monitor. So a heartbeat means we check that the file has been touched recently enough. So it checks modification time. You beat your heart by opening it to write and then immediately closing it. The way that a process can know which file to write, of course you can, explicitly tell it if there's a way for you to tell it, but NColony will always keep the process configuration in an environment variable that the process can see, which is NColony config. So the process can literally read the NColony config and figure out where to write its heart to and how often to beat it. So that's very easy because then you make sure that both things are seeing the same configuration, the heartbeat checker and the process that needs to beat its heart. So if you want to modify it, you modify it in one place, which is the NColony configuration. It uses a custom JSON key. So remember that like all these things are basically just JSON files. It uses a custom JSON key that you most of the time don't have to worry about, but if you read the documentation, it's right there. And if you're writing in Twisted, you can literally just add a service that will make sure that you beat your heart, so you don't even have to think about it. And as long as the Twisted event loop is running, then your heart will beat. And again, this is subtle, right? We said that health is subtle. Just because the Twisted event loop is running doesn't mean that you're really healthy, but at least we know that you're not really, really hanging, right? You can't be crashed because otherwise you won't be doing anything. You can't be stuck in an infinite loop because otherwise you won't be doing anything. So at least you're sometimes responsive to the event loop. Maybe every time someone tries to get to your port 80, you crash. That's, of course, regrettable, but at least you're kind of up. And like I said, the definition of healthy is complicated. This health checker just checks for heartbeats. So it will decide that you're healthy and not to kill you if your heart is beating. But if you're not using Twisted, you can write your own heart beating service, right? If you're using Tornado, if you're using Flask, if you're using some Ubuntu, you can just beat your heart yourself. That's fine. And the easiest way to configure it is just to read the NColony configuration from the environment variable. But if somehow that's unavailable, you can just pass it explicitly. The way that the hard checker is gonna work is it's gonna send a message to restart the process when it sees that the process is dead. So the hard meter is really nothing more than just another process that the NColony will bring up. And if it crashes, that's very sad. But as long as it's up, it will check the heartbeats for everything else. And if it sees that the heart is beating, the heart is not beaten for long enough, it will tell NColony to restart the process. It won't restart the process itself, of course, because then it will be its parent, but it can tell NColony to restart it. So NColony does have adoption and reaping. What it means is that it's safe to use as PID1. The main places where you'd want to use it as PID1 is if you're running a Docker container, because the Docker container is the first process you run. From the outside, it's not PID1, but from inside the Docker container, it's PID1, which means if a process inside the Docker container has its parent die, then that process becomes a child of PID1 inside the container, which is, if you start with the NColony process, will be NColony, and NColony will be it. If you use PID1 as something that does not reap processes, it's going to be pretty bad for you, because whenever this happens, whenever the father dies before the child, then the child, if it's not reaped, it will become a zombie. It will fill up your process table, which, unless you have very, very carefully configured your container limits, will actually crash your entire VM or the machine that you're running on, and not just your container. So that's going to be a lot of fun, and you definitely don't want to have that fun happen in 3 AM. So you always want to make sure that, so if you're not using NColony, if you're using anything else, you can use something like Yelp's dummy-init to make sure that something is going to be there as PID1 and to reap your processes. It can restart any process you asked it to, and it can restart all of them at once. And there's another feature that's right now in review, which allows it to restart like a group of processes. So you tell it all the processes that belong to like that specific type. It does have a heartbeat checker. You can tell it to run any processes a given UID or GID, which is very, very good for security, obviously, because you do not want some processes running as root. And it does have 100% unit test coverage, as I've said. It is completely Pylint clean. It does not have good support for daemons. Some of these things have like all kinds of hacks that if your process demonizes, they will have some foreground shimmer around it. So DJB Tools has its own foreground shimmer, and Supervisor D has its foreground shimmer. And I've looked at these things, and they're horrible and like buggy by design in that they cannot work correctly. And if you really want a foreground shimmer, you can get either the one for DJB Tools or Supervisor D. They work fine with NColony. NColony does not come with its own because that is a space I felt is bad and also crowded. So many reasons why I don't want to go in. It does not have more contributors. Other than Mark Williams, who I thought might be here, but apparently he's too busy to attend, who has helped me a lot with pull request reviews. No one else has contributed much to the project. So if you are interested in like low-level Unix stuff or Python stuff, or just writing quality Python code, and even if you just want to pull request reviews, that'll be awesome, and I would love to help you get started. It does not have a lot of users. It does have a few users. We've used it in production in a couple of companies, and it's never had a problem. Sure, like only 10 or 15 servers, but running continuously for days and weeks at a time, never had a problem. So it's pretty reliable. And part of the reason it's that reliable is because NColony is pretty much a shim around a much older thing in Twisted called the process runner, and it just adds a configuration layer. So most of the runtime stuff is like things that are very, very stable and have been debugged in Twisted for years. Might be decades at that point. So what can you do? So if you want to try it, if you have a Docker container that needs to run more than one process, or if you're not using containers and you want to run several processes or anything like that, please try it. in if there's a feature that's missing or if there's a problem you're having. Issues are open and it's really, really easy to find my email. In fact, it's linked from the first link that you saw in the presentation, so it's really, really easy to find my email. Please let me know. I'm always happy to hear about people using it. If you want to review PRs, God bless you. I'll really be grateful. If you just want to talk to me, understand why it is that I'm doing that, or you have any question that I didn't answer, and you're, I guess, too shy to come in the Q&A, please talk to me. I'm zadka.moshe@gmail.com, and every other way to contact me on like half a dozen social media platforms is linked from cobordism.com, which is a weird math joke, but that's fine. I'm a weird math guy. Anyway, so if you want to talk to me about that, I'm always happy to spend like hours and hours talking about these things. Thank you all very much. Any questions in the back?
I have 5 questions, so I will let other people, I will yield whenever someone comes up with my 5, so I don't dominate all the questions. So typically, do you run NColony as a system user or as root? I believe you're running it as root because of your as GID and...
Typically I'm running it as root. Again, it depends a lot on what you want to do. So if you're inside the Docker container, usually you want to run as root, and you want to kind of use user namespace mapping if you really care about running as different users. Of course, if you're not running it as root, you won't be able to use the UID GID features. So it's basically like a very, a basic definition. Usually in containers, it makes sense to run the root thing as root and all the subsequencing as non-root. But again, that depends. I've used it as non-root before.
My loop is looking for anyone to yield to. I don't see anyone, so I'll go for my second question. NColony, what's the NColony equivalent of monet status?
So that's a good question. Currently, it's basically reading the log.
Oh, okay.
which kind of sucks. I do want to add a layer that kind of lets people know status, and I do even want to add like an RPC layer. There's like a ticket and like even a design for that. Like I said, it's really lacking contributors, and I think it's even more lacking like a lot of use cases. So I'm always happy to hear people who want something that they can't get from NColony. Yes, there's a question here. No, usually those things are really problematic, right? Because if you're counting on those to work, then what happens when one of those crashes? Like you're gonna have to restart all your dependencies, and that's usually not good. So usually I really encourage people to just write their processes in a way that doesn't assume that, because it's really hard to do the right thing from the process monitor layer. For example, the process can be up, but maybe it's not responding to requests yet. So you anyway have to do like a retry loop, like it's startup, and you might as well just not give people the illusion that you're really helping them.
I'll ask one last one. I'll cut it short. What is the NColony equivalent of doing monet start engine X from a process point of view, not from inside of a Python?
That's actually like, so basically this is
the equivalent of what we saw the first time.
So this works whether you do it before you run NColony or after you run NColony. It does exactly the same thing, which is like, start by thing. So you can start, so if you want to add Nginx after NColony starts, it's the same thing as adding Nginx before NColony starts, which is doing that. Which is actually pretty neat, because that means that if you restart NColony for any reason, it will just start with the configuration that it had last, which is usually what you intend. Yeah. So there's no messaging infrastructure. It just runs processes, and it really looks at the files. So it basically just looks at the directory and sees if there's any files that are new or changed. So that's why add just works, because it literally just creates a file. Like, so this will also work after NColony starts. You can literally just create a file, and NColony will be happy to run it. So it doesn't use any messaging infrastructure. So there's one there and then one there. Yeah. Supervisor D does do the right thing parent-wise, yes. Sure. Right. So So unfortunately, that's not something you're gonna do without any downtime. I usually feel like that's like if you can't take the downtime for like one instance, then you're probably in a bad spot anyway, right? Like things are gonna maybe you do it like with a high level load balancer or like kind of things like that. But ultimately, any given instance can die. So I never want to try and do like a complicated in-place upgrade of NColony. That sounds like it would be dangerous.
If not, my application generates one message can be intercepted by NColony to do some action.
So NColony does not try to intercept messages. If you want to explicitly message NColony, then I don't have an example here, but basically there's NColony message, NColony control message, which will explicitly message NColony. Again, it will do it by creating a file that is ephemeral, so NColony will kind of delete it after it sends the message. So if you want to get NColony to do something, you don't write to std out or open a socket, you just write to var run config messages in this case, var run messages in this case. Yes, there's another question in the back.
So is there a way to specify one process to start after another?
So no, there's no dependency. Like it starts all the processes as soon as it sees them. If you really want the process to start after another, the best way is to have that process when it's decided it has started enough till NColony starts the other one by literally doing that. If you because what does it mean to start a process after another, right? Like I can start start this one, but that's probably not what you're asking for, because why are you asking me to start one after the other? Probably the second one needs something from the first one, but if I just started the first one, it hasn't had time to do anything, right? Python takes a few hundred milliseconds to start nowadays, right? And especially if you're using PyPy. So you probably want start to mean that I'm up and running and ready to go and ready to service. The only person who really knows that is the process. Or if you kind of write a manual health checker, you can do that. So you probably want a layer that's higher than the process manager, because you want to make sure that and again, usually that's an anti-pattern. Usually you want to be able to start all your processes at the same time and kind of have them kind of poke each other and kind of achieve stability. That's much more reliable, especially if something restarts, right? It's gonna have to anyway kind of have all its friends talk to it again. Yes. They don't synchronize through environment variables. What they said is NColony, when it runs a process, it will put the configuration of how it ran it in an environment variable NColony config inside the process. So if that child spawns further children, they'll inherit the environment from the parent. But at that point, NColony is not going to know anything about them. Adoption only happens when the parent dies, and then NColony doesn't do anything but just wait for them to die and reap them. It doesn't do anything sophisticated. It doesn't know. It doesn't know which parameters are the right ones to respawn them. It's not going to try that. It's going to, restart the parent as it's due, and when these children die, at least it's going to reap them, so they're not going to stay zombies forever. But if that parent just starts process willy-nilly and they don't die properly, NColony doesn't do anything to prevent you from filling up your process table. That just will prevent zombies. Again, usually often this is like, if you're really doing it a lot, this is a Dante pattern. Probably what you should be doing is, instead of spawning these processes yourself, if you really care about them, again, NColony is reconfigurable in runtime. You can just tell NColony, hey, I also need that process up and running. Here's like the parameters to run it by doing something like that. And then NColony will of course take charge of that, because it will be the parent and because it knows how to start it and how to restart it. I hope that answered your question. I'm not really sure what the use case here is. Cool. Anything else? Sure.
If I wanted to cause something to run on the other unit, running there, by
Yeah, if you have any agents there that you can create files, that's fine. Yeah. So again, it literally just looks at the directory you told it to. Cool. I think I heard something from there. Anyone over there? Okay. Cool. Thank you all. Good questions.
I have a couple-minute break if you want to grab a quick bite, but we won't be too long. We're setting up. So the next talk is actually another one I'm super interested in. I have a few monolithic Django things around that I would like to split up a little bit more, and I've super been into lambdas and other kind of, this isn't a lambda talk, I know, but just the idea of splitting something up into microservices sounds super interesting to me. So Dinesh will help us learn more about how to split something up or how to use microservices with Django.
Sorry. Yeah. All right. Thank you, everybody. Okay, my mic seems to be working better. So I'm Denise Joshi. I will be talking to you about designing fast and scalable Python microservices with Django. A little bit about me. I'm a senior software engineer. I graduated from Georgia Tech in 2009 with a master's in computer science. My specialization was in distributed computing. I'm a Python enthusiast. I've been using Python for over a decade now, and I really like the language. So let's look at the outline. First, let's talk about a reference application. This will help us set the context in the application that I'm trying to optimize. And then we'll look at the request and response pipeline. This is very crucial to understand how Django processes its requests and responses to help us stay away from some of the issues that one encounters normally, which slows down your requests. Then we'll look at the middleware and also the ORM. And then let's talk a little bit about measuring performance, and then the kind of last resort that you have in speeding up your services, which is caching. And there is one more thing that we can talk about is asynchronous processing, request processing, which generally is very helpful in any microservice architecture. And hopefully we'll have some time left over to answer some questions. So here's a standard application that you will normally have, a Django application which is connected to a database for persistent storage like Postgres. The application might be also connected to a cache running Redis or Memcache. That's pretty standard in the industry. And some people make use of celery tasks along with a queue, and Redis also works fine. So Celery is a framework that allows you to defer the execution of your of code. So it executes your task in a separate process. So you don't need to execute it as part of your current process or thread that's executing your request. So it's a fairly standard thing in Python. So this application can be built with Python 2 or 3, doesn't really matter. We have Python 2.7 being used right now in the industry. A lot of people are moving over to Python 3, but it's going to take some time. The packages that you would normally have is Django REST framework. For those who don't know about Django REST framework, it's a package that gets added onto Django, which makes it easy for you to build services, RESTful services. You'll probably have to install Django Redis, PsychoPG2, and Celery. Again, these are 3 packages that will allow you to implement persistent storage and caching, as well as queuing asynchronous requests. So the first thing that is important to understand is the request and response pipeline. Django has a whole lot of things going on when it receives a request, but the main pieces are when a Django process receives a request, your WSGI container is invoked, and it invokes the WSGI handler in Django. When that handler is invoked, it basically creates a very simplistic HTTP request and then passes it on to the Django handler. The Django handler does a little bit of things in the middle, but then the bulk of the processing is handled in the middleware. And middleware, you can think of middleware classes as as a pipeline of functions that get executed one after the other. Some of the middleware adds additional data, or it extracts some data out of the request that it has received. But it's worth to note that if you have a whole lot of middleware, then your request processing pipeline becomes quite deep. Eventually, that once it's done processing throughout the middleware, it invokes your view function. And view function is the actual function that your application business logic lives in. This is where you do your actual business logic. You might call out to the database, look up something in the cache, make a call to an external service. And then once you're done and you prepare a response for the end user, you then send that response back. But it doesn't go directly back to the client. It goes out via the response middleware. So there are 2 kinds of middleware, request and response middleware. Some middleware act as just request middleware, some act as just response middleware, but some of them process your request as it's coming in and going out both. So the key thing here is that your request duration is a total of the amount of time that you take to go through the entire pipeline. And the advice here is not to block any part of this pipeline. Do not make an outbound blocking call to a socket, or do not write stuff, a whole lot of stuff to the files, because that will slow down this request pipeline. And it matters when you are processing requests at 1,000 requests a second, this pipeline will quickly add up. The next piece is the middleware. The middleware can act to slow down your request. It also acts to speed up your requests. So, for example, I've seen in applications, yes. So it won't block the whole server. The question was, if we block the request pipeline, does it block the whole application or does it block just that request pipeline? So the answer is that it just blocks that one request. It won't block your entire application. But think in case you have, let's say, 8 processes and you're running Django 2.7, then, Python 2.7, you have 8 processes and all of them are slow, your aggregate throughput is going to drop if your request pipeline is slow. Yes. That's correct. So it's important for you to audit your middleware. A lot of times I've seen in applications, they have unnecessary middleware that's left over. You don't use it anymore. All it's doing is it's adding to the entire request pipeline. It's slowing down things because it runs into object allocation. You are stressing out the CPU. You are adding more memory allocations. It's just unnecessary overhead, slowing down your requests. And you can add middleware that also somehow, it also helps speed up your request. So for example, you can add conditional get middleware. So it basically sends out an e-tag to your HTTP response. E-tag is sort of a small, it's a hash which is used to identify the content that was sent back. And if your client supports e-tags, then it will the conditional get middleware will terminate your request even before it gets to the heavy stuff, and it will tell the client that you already have the latest version of this asset. You don't really need to come to me and request it further. So this can actually improve your throughput by sending back a response even before your view function gets invoked. There is also gzip middleware. The idea of the gzip middleware is to compress your response. The idea is that the number of bytes that you transfer over the network affects the speed with which you can process requests as well, right? And this is in some ways a micro optimization, but the smaller footprint of your request and responses definitely help with your throughput, because then you have lesser memory pressure, lesser CPU cycles are spent in trying to put stuff onto the network or read stuff out of the network. But it does impact your CPU utilization, because whenever you run any sort of compression in the request or response, you are burning more CPU to compress your requests, but or responses. But the data goes back to the client much faster. And then the other thing you can do is add a cached session to your application. The idea here is that Django typically stores all of your sessions in a database. A SQL database is very slow compared to something like Redis or a cache like Memcache. And what you get out of cache sessions is that sessions are ephemeral. A user logs in or he sends some authentication, and these sessions will get recycled over time. Even if you lose the cache, it's not a big deal. You log out a bunch of users. But on the upside, you have a lot of advantages. Now, typically, Redis is anywhere between 10 to 100 times faster than your typical SQL database. So you can make use of these things to accelerate your sessions as well as accelerate your requests that hit your Django server. Just to emphasize my point, I had an application which had unnecessary middleware, and after removing that middleware, the throughput of the application increased. It was the improvement on the application was not a whole lot, but when you are trying to squeeze every single bit out of your Django application, you really, a 20-30% improvement in request processing speed also adds up. And so on the left side, you see the number of requests being processed relative to the, on the right-hand side, what you have is a optimized Django application which has lesser middleware, and the difference is about 20%. So it will vary between different applications, but unnecessary middleware just adds more bloat to your application. So let's look at the ORM. ORM is like the centerpiece in Django. Anybody who uses Django makes use of ORM. And there are things that you could do with the ORM settings that will help you speed up the your application. Some of the stuff that you could do is like add indexes. This is like general database thing, right? You can just add indexes, but Django makes it very easy to add indexes to your model. So if you are filtering or you are searching through certain columns, you definitely want to add indexes. You want to also enable persistent connection. This is one of those things that I thought with Django 2.0 they would fix, but I noticed that the connections that you have are not persistent connections. And why does this matter? If you look at a connection establishment time, every single request that your Django application takes in will incur a connection establishment time to your database server. And it is okay if you do a three-way TCP handshake, but if your database has any sort of TLS or security SSL stuff that is enabled, that the SSL session setup is a very expensive protocol, and it takes time to establish sessions. So it slows down your request quite significantly, and Django has this disabled by default. So it's one of those things that you run into quite often. Also use connection pooling. Connection pooling is slightly different from persistent connection. So what happens is when a connection drops, if you have to reestablish the connection to the database, you will incur the cost of reestablishing connections. But with a connection pool, there's a pool of connections that are already established to the database, and you simply pick the next connection and you move on and let the driver reconnect or refresh the connection pool. So this also adds up when you're trying to optimize your request throughput. What you can do on the code side with the ORM is to use prefetch related. The nature of a SQL database is that it is generally normalized. And when you are responding to the user with a bunch of data, it's more than likely that you are actually making use of fields that come out of multiple models. And what that means is that Django has to stitch those models together. The ORM has to go and join those models together in the background. And if you are doing this in code, it's just going to slow you down. So Django comes with something called as prefetch related, and what it does is it prefetches when you fetch a model and it has relationships, it prefetches all of those at once, and so you don't have to keep going back to the database over and over and over. Imagine if you are processing a list of objects and all of them have a related field, you are going to go back to the database n times, depending on the number of objects that are in your result set. So prefetch related works with many-to-many relationships. Yeah, go ahead. Doesn't what? So the question was that does prefetch related interfere with the database execution plan? So the way prefetch related works is that it will fetch all the rows that it needs from all the models, and then it does the stitching behind the scenes for you. There is another thing that's called select related, which will do an actual database join. So yes, prefetch related and select related add an additional load for that one query. But if you are amortizing that over like 100 objects or 1,000 objects or 200,000 objects, it doesn't add up a whole lot. So the comment here was that you can potentially bring in a whole lot of data, and you can crash your database, sorry, not your database, but your Django application process. That is absolutely true. And so Django has this ability of pagination. So if you are doing any sort of web services, you want to ensure that you have pagination on those web services. You bound the response. You don't pull in like a million records. If you say /all or whatever is your REST endpoint, you want to make sure that you have a sensible default page size, and that the user can, or the client can keep paginating through that query set. So that's one of the best practices. I should probably add that in. So yeah, single valued relationships are something that you can use with select related. The big difference here is that one actually results in a database join, the other one actually is done in Python. And then also reusing query sets. A lot of times what people do is they have query sets and they keep creating new query sets. And query sets internally have a cache. So if you're going over the same objects several times, it makes sense for you to keep the query set around if you're going to reuse the objects. So you don't have to keep going over and over back to the database. It's just going to use the cached objects. Just to emphasize my point, like, some of the things that are, very, very simple, but a lot of people make mistakes is, there's a Pythonic way of getting the count of collection, which is, you do a len on the collection object. While in Django's ORM, what is recommended is you should do whatever is the query set dot count. And the difference is that one actually leads to you going to the database and getting all the records and then counting those records in Python, versus actually, just executing a select count star from the database. So just to emphasize my point here is, if you look at what happens with len cars, it is doing a select on the entire table, and then it comes back and it will count those rows in Python, and it takes 170 milliseconds. This is retrieving, let's say, 200,000 records, right? And when you do the cars.count, you'll see that the time is only 15 milliseconds. So the difference is an order of magnitude, more than an order of magnitude. And so it makes sense for you to like audit your code, and a Python programmer doesn't think twice before they do len of something, and it makes a very big difference. So that brings me to another topic, which is measurement, right? You can optimize all you want, but premature optimization is sort of a root of all evil. And so I found that Django debug toolbar is one of the most useful tools when you're dealing with any sort of Django REST service or a Django application in general. So before you break out your Python profilers or your OProfile or whatever you use on Linux or Mac or whatever it is, just give Django debug toolbar a chance, and you'll see that it's very useful. So for example, it has a lot of tabs, and the most used tab is on the SQL tab. This tab gives you an insight on what your application is doing. It shows you the settings, it shows you a bunch of things, and what it shows you is the SQL queries that your entire service created on the database. So so if you're using a bunch of ORM queries, it will show you a bunch of select statements. It will show you duplication, data duplication, or if you're making redundant queries. One of the most useful features it has is to do a SQL explain. SQL explain gives you the query plan on the database. So it exposes situations where you don't have indexes, or you're doing something that the SQL database doesn't like. This works generally with Postgres as well as MySQL. I've not personally used with MySQL, but it's one of the most useful utilities to have, right? It gives you a visibility into what your application is actually doing. So the one of your last resorts is caching. So let's see what caching does. It's very useful for read-heavy workloads, right? You can install Nginx or you can install whatever, but with Django's caching, what you can do is you can cache at a much finer level, which is at an object level or at a view level. It typically boosts your performance quite a lot. And this is like, but it also introduces a situation where now your cache is going to be very, it's going to duplicate your data essentially, and then you have to maintain the coherency between your database and your cache, and that's a difficult to do typically. So invalidation logic is very complicated. So if you are storing like 10 keys for objects, now you have to figure out which objects generated those 10 keys, and it just gets very complicated. So, but caching is one of those places where you can, if your services are simple and small, you can cache them very easily. So just again to emphasize my point, caching adds a lot of performance at the cost of complexity of invalidation. So this is just an experiment that I ran. Let's not focus on the specific numbers because the hardware I was running it on wasn't very powerful. But if you see, the uncached service can do about 100 requests a second, but with the caching on, you can do about 300 requests a second. This is using Redis and vanilla. I'm not doing any sort of performance tuning right here. So, and then finally, we come to asynchronous processing, and what is this generally useful for? So remember this slide, right? Like we talked about not blocking anything in your request pipeline, and that's still true. But you can do one thing, and that is whenever you get a request, you can fire off a asynchronous query or an asynchronous task. And going back to our Django application, let's assume that you have to send out a notification when some event on a database occurs, right? So let's say you insert some entry and it's an interesting thing for you to do. You need to send a notification. You have two options. You can actually send it as a synchronous call or even an asynchronous call right then in the Django application process and call out to an external service. But then what happens is if the service is down or the service is flaky or it's slow to respond, if you make a synchronous call, it will definitely block. But if you make an asynchronous call, it's not going to block. And there are two ways of making asynchronous call. You can spawn a thread in Python, which everybody knows is not the best thing to do in the world. And that thread has to live on until your request is actually fulfilled, or you have to keep retrying in that thread. Now, what happens if you get 10,000 requests a second? All of a sudden, now you have 10,000 threads to deal with. Then you get into the whole aspect of building a thread pool, and then it just goes downhill from there. So the best thing to do at that point is to actually, put that request onto a queue and then, send it off to, or basically use a salary task to actually execute that request. It all depends on your application. So let's say you get a request and you do something to a database which is interesting to you. So for example, let's say you want to audit something or you want to log something to an external service or send a specific notification to that service. You get the response back from the database, and then you know that this is the thing that you need to contact service X and you need to notify it. That goes onto a queue, and then the celery task goes and executes it. And in the celery task, you have a lot more time, and you don't have the pressure of responding immediately to the client. You can say, hey, I've done something for you, and here's the result. But in the background, you're like sending a notification to the service which you could have done in the whole request pipeline, or just asynchronously do it using celery tasks. So there are plenty of things. One example is when you want to rebuild, let's say, Elasticsearch index. You don't want to do that in the context of the Django process. You want to do it asynchronously because it's time consuming. So yeah, that's pretty much it. And I think we've taken a few questions already, but yes. So Tornado is, yes, Tornado is slightly different from Django. Django basically is a framework which is not meant for doing IO-bound workloads. Tornado, on the other hand, is meant for doing a lot of IO bound stuff. When you typically want to do something asynchronously, it's basically because you're juggling a lot of IO calls, right? Whereas with Django, what your typical request workload looks like is you get a request, you want to do a bunch of database queries, and you want to generate some response, a large response, and then you want to send back that response. Whereas with Tornado, Tornado is very similar to anything that's built on top of libuv, which is like Node.js or anything, which allows you to take a bunch of large number of requests and juggle them for an IO-based application. Yes. Yeah, you can scale this horizontally. You can add more databases. There are things that I didn't even mention here. Is you can add read replicas to your database, and if your workload is read heavy, you can certainly go and scale that. Django's database routing is not the best in the world. Yes, if that is your workload, then Tornado is definitely the right choice to go. Django is not meant for doing a whole lot of asynchronous request processing in the way Tornado is designed. So when I say it is doing an asynchronous call, under the hood, it can, I'm not entirely certain how you do the actual async socket call to the queuing system, because that just depends on which queuing system you use. The idea is that with Celery, you are actually invoking a Python function, and what Celery does for you is it packages up all your request arguments, and then somehow sends it over the queue to another process which has a bunch of Celery workers, and the actual communication, I'm not certain. It depends on the specific queuing mechanism that you use. If you're using Kafka or you're using Redis, I'm pretty certain it's using something async. Yes. That is on the other side, but I think his question was more that when in the context of the Django application, when you say, hey, defer the execution, like delayed execution for the Celery task, how does that communicate? What is the communication channel? Whether it is right, but whether Celery is actually internally using AIO, I'm not 100% certain of that. Yes. So I have experience working with Elasticsearch, but not with MongoDB. I've found Django to be most useful when you're using it with a SQL database, because it comes with migrations, and all the working with SQL and Django is a pretty awesome thing. Yes. So Cassandra is I want to say it's a NoSQL database. It exposes a SQL-like interface, but it's not really a SQL database in the traditional sense. So the performance considerations that you would have to build an application with Cassandra are definitely going to be different. The way it stores data, shards data, and scales is very different from a traditional SQL database. So I have not had any experience integrating Django and Cassandra, but you would want to play to the strengths of the database that you are connecting it to. I think so, yes. For Cassandra, I know for sure. I'm not sure about MongoDB. Yeah. Yes. Socket. So just to repeat his question is a common configuration which I probably did not mention in this slide is that people put Nginx in front of your Django application, and both processes are actually inside the same host. So they are communicating over the local loopback interface. And is it worth actually adding the gzip compression in the Django process versus just letting Nginx do the SSL termination and doing the gzip compression? Personally, I would need to benchmark this to really authoritatively answer that question. The thing that I would mention is that Nginx or whether it's Django or Python, right, at the end of the day, is using the gzip C implementation. It's not like you're writing gzip in Python. It's actually calling out to some native library. So it may not be as performant as Nginx, but it is still right up there with Nginx. Again, I need to benchmark this in order to say it authoritatively. If you're using Unix domain sockets or local communication, so it doesn't really matter a whole lot. Again, I don't like the idea of you copying or moving memory from one process to the other process. If your responses are very large, then you may benefit out of it. In other cases, you may not. So yes, so so his point is like it's usually when you are talking over the network that it's going to make a whole lot of difference. So yeah, I kind of agree with that. There are two. Yes, there's somebody at the microphone. Sorry, I didn't notice.
Yeah, since I'm at the microphone, I'll go ahead and ask. It just so happens last week I was teaching a Django class, and one question I got from students was, okay, I'm new to Django. Should I try and learn Django 1.9 or should I learn 2.0? How would you answer that question if they're new?
I would start with 2.0. There's nothing wrong with learning 1.9. Everything that in 1.9 carries over to 2.0. The thing is that I think the documentation and everything is kind of good for both. I would personally just pick 2.0. Yeah. Stateless application. What would I get rid of in the architecture? Yeah. Yes. Okay, so for a stateless application, which middleware should I get rid of? So that's, I would need to see the list of middleware, what kind of application it is. But I mean, nothing specific jumps at me right now. So it depends on what kind of an application it is. Just one more question.
Have you tried this in container? And how will you access the resource from container?
So it's standard network sockets. So it doesn't really matter if you're running inside a container or elsewhere. It's still going over sockets. So if you're using Docker or something, you'll use some service discovery and connect to its socket and IP address that the service discovery gives you back. Any more questions? Yes. Comparing performance between Django and Flask, that's the question. I would say, again, it depends on your application. Flask is a very lean framework, which doesn't come out of the box with many things. Django is a very prescriptive framework, which has a bunch of things. You can get rid of things from Django or add stuff into Flask to build your application. So, you would need to benchmark, and it depends on the specific plugins or libraries that you choose to build your application well. Questions? I think we're good. Thanks.
Okay, everyone, I think there's still more food to be eaten, and there's conversations to be had, and there's jobs to be gotten and gained, and employees to be had. So employees, employers, around that poll's the typical place. That's the meeting place. It'll be a little bit easier to find people. Hopefully you can find someone tonight, and you can find a job tonight. Let's have a great conversation. I really appreciate it. We'll see you next month.